Hey guys, today we're going to look at section 3.3, which is on derivatives of trig functions. This is going to be a relatively short section compared to the other ones that we've done recently and that we're about to do, but it's still an important section. So I've got this organized first into what to memorize, and then I want to show you where the stuff comes from, and then we'll do some examples. So this chart you should just memorize, even though you can refer to a chart. You should know these, especially if you're going to take Calc 2, because these are going to come up a lot. So let's just look at them. The derivative of sine is cosine, derivative of cosine is negative sine, and the derivative of tangent is secant squared. If nothing else, memorize those three. Once you know those, the others are kind of related. The derivative of cotan is negative cosecant squared. Derivative of secant, well, I guess this is another one you just have to memorize. Derivative of secant is secant tangent. And derivative of cosecant is negative cosecant cotangent. Now, just a couple of tips on how to keep this straight. Notice every one of these where you're taking the derivative of a cofunction, those are the ones that are negative. Derivative of cosine, derivative of cosecant, and derivative of cotangent, those are all negative. And if you look at, say, like the cosecant and the secant, they're kind of related. Derivative of secant is secant tan. Derivative of cosecant is cosecant cotan. So it's like you just throw a co on there. Same thing going on with the secant, derivative of tan and derivative of cotan. This one is secant squared. Derivative of cotangent is negative cosecant squared. So there's some patterns in there that can help you memorize these things. All right. If you look in the book, they derive where the they derive derivatives of sine and maybe cosine. I think they only do one of them. I'm not going to derive this from the definition, although it's certainly possible to do so. What I want to do, though, is just look at the graph of sine here and draw its derivative. Let's see. I'm going to use green for derivative here. Okay, so if we look at this graph and we trace along it looking where it's going down and up and down and up, we know that its derivative is going to be 0 at the places where we have peaks and valleys. So the derivatives are going to be 0 there, so I'm going to draw that in. And notice from here to here, the slope is positive, so that means the derivative is positive. And then from here to here, it's going down, so the derivative is negative. So if you just continue this on, you'll notice you get this graph right here, which is the cosine graph. So the original here was sine. And when we draw in its derivative, we get cosine. Now, if we come down here and look at cosine, and we draw its derivative, let's see, its derivative is going to be 0 here, here, and here. And I guess I've got one more on here. Derivative is going to be 0 in all those places. Derivative is positive here. So we get this. And if you look at this graph, the green graph here is minus sine x. The red graph is cosine x. So just by looking at this, we can, one other thing maybe I should mention. If you look at, say, right here, at minus pi over 2, if you were to draw in the tangent line, it looks like the slope is about 1, and sure enough it is. So that tells us that right here, this point, if I had drawn this very well, this point would be up here at 1. This would be down here at -1 because the slope of this line is -1. So if we just draw this carefully, you might look at this and guess that cosine and sine, or cosine and negative sine, are the two derivatives here. And so that accounts for this formula and this formula. Now, what about the others? Well, it turns out we can derive all the others. Once we know the derivative of sine is cosine and the derivative of cosine is negative sine, once we know those, we can derive these others by using the quotient rule. Let's come down here and look at it. Let's do the derivative of tangent. Now, first up, you have to recall that the tangent of x is equal to sine over cosine. So let's take the derivative of tan. Well, the derivative of tangent is derivative of sine over cosine. And we've got to use the quotient rule here. So we get low d high. Derivative of sine is cosine, minus high d low. So derivative of cosine is negative sine over low squared. Okay, now nice stuff happens up top. Here we've got cosine squared. This becomes plus sine squared. And we have a Pythagorean identity that tells us cosine squared plus sine squared is 1. And the reciprocal of cosine is secant. So this is secant squared x. So that gives us that the derivative of tan is secant squared. Now we can do the same thing with the derivative of secant. If we want to take the derivative of secant x, we can rewrite this. Remember, secant is the reciprocal of cosine. And we've got two options for how we can do this. We could use the quotient rule on it. Let's do that. We get low d high, which derivative of 1 is 0, minus high. Then d low, derivative of cosine is negative sine, over low squared. All right, so what this winds up giving us on top is sine x and then over cosine squared x. All right, that's not exactly what we said. Up above, we said derivative of secant is secant x tangent x. Well, let's take this apart. Secant and cosine, or sine and cosine, I'm going to rewrite this as sine x over cosine x times 1 over cosine x. I'm just breaking that cosine apart like this. Then sine over cosine is tangent, and 1 over cosine is secant. So that's one way we can derive this. The other way we could do it, let's see, I've got enough room here, I'll do it in green. The other thing we could do is, starting from here, we could take this and rewrite it as derivative of cosine x raised to the negative 1 power. To do the derivative of this, we need the chain rule. So we'll get minus cosine x to the negative 2, Then by the chain rule, we've got to multiply by the derivative of cosine, which is negative sine. And that gives us, let's see, the negatives cancel, and we're left with sine x over cosine squared x. And that's the same as what we have up there. So either way we do this, we wind up getting tan x secant x. All right, I want to do some examples, but we'll save those for the next video.